Welcome to this video. In this video, we are going to look at an example of equation we might see in our forthcoming examination. So the question says the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, and 3p3. How many unpaired electrons are there in the element? Now, this question is coming from the concept of unpaired electron in electronic configuration. Remember, there's a topic called electronic configuration which deal with the arrangement of electron in an atom, right? Good. So in that topic, we are going to be looking at the concept of unpaired electron. When we say something is paired, it means they go in two, right? Two. So when we say unpaired, it means normally the thing is supposed to go in two, but it is now one. Alright. So for you to be able to answer question under concept of unpaired electrons, you must have an adequate knowledge of the electronic configuration by Bose method. Remember that I told you there are three methods of electronic configuration: the electron dot and cross method, the SPDF notation, and the Bose method. Alright. Now from this question, you can see that the electronic configuration given to us is the SPDF notation, which is also called the orbital notation. So the SPDF notation, which you can also call the orbital notation, was the electronic configuration given to us for us to determine the number of unpaired electrons. So for you to determine the number of unpaired electrons, you must carry out your Bose method of electronic configuration. So remember that in Bose method of electronic configuration, as we have 1s2, we have 2s2, we have 2p6, and we have 3x2, and we then have 3p3. Alright. So remember that we are going to write the degenerated orbital of each of these orbital. Remember, degenerated orbital are gotten when orbital are split in the magnetic field, and the degenerated orbital are being given by the magnetic quantum number, isn't it? Good. So now, and remember, in the magnetic field, s orbital isn't splitted. So for that reason, we only have one box. So we draw the electron present in this orbital. Remember, they told us there are two electrons present. So that's why we are having two electrons here. So for the 2s orbital, we have something like this. For the 2p6 orbital, remember that the p orbital, is degenerated 3 times, meaning that it has 3 suborbitals. So this is the 3 suborbitals of the p orbitals. So now let's feed the 6 electrons into them respectively. Remember that there are a lot of laws governing electronic configuration. So we are going to obey those laws in filling these suborbitals. So in those laws, we are going to look at that laws in our next video, where we shall look at the Pauli's exclusive principle, the Ohm's principle, and the Albers principle. So this is what those three principles are what are our guidance in this process of electronic configuration. So now for the 3s orbital, we are going to have something like this, and then for the 3p3 orbital, remember our p orbital is divided into 3 suborbital. So we have 1, 2, 3. So no other electron that is being left for us, right? So now the question is, how many electrons are unpaired? When we mean unpaired, how many electrons are not occurring in twos? This first electron, there are two here, there are two. This one is two, this one is two, this one is two, this one is two. But this one is occurring in one, this one is occurring in one, this one is occurring in one. So how many electrons are unpaired here? There are 3 electrons that are unpaired. True or false? True. So it therefore means that the answer is what? C. So this is how to answer questions under concept of unpaired electrons. So but before we go, do not forget to react to this video, like this video, and give us a follow as a form of encouragement for our good work here. And also share this video to your friends who will also find this useful for their forthcoming examination. Bye till we meet again in our next video.